Hi, and welcome to episode 23 of my free Java video course. My name is Markus Biel. In this episode, I will give you a high-level introduction to the Java Collections framework. Unfortunately, there are several overloaded uses of the word collection. Let me clarify the various meanings up front. The different use cases are a collection without any IT relevance as a compilation or group of things. Second, the Java Collections framework, a library of different interfaces and classes. Third, a collection as a data structure. Think of a box or container that can hold a group of objects like an array, for example. Fourth, the Java Collections interface, one of the two main interfaces of the Java Collections framework. And fifth, java.util collections, a utility class that will help you to modify or operate on Java collections. This episode is based on chapter 11 of the OCP study guide. The book is packed with knowledge. As a great fan of the authors Kathy Sierra and Bert Bates, I recommend you to read this book, even when you don't plan to get a certified programmer. So, what is the Java Collections framework from a high-level perspective? First of all, it's more like a library, a toolbox of generic interfaces and classes. This toolbox contains various collection interfaces and classes that serve as a more powerful, object-oriented alternative to arrays. Collection-related utility interfaces and classes that assist you in using the collections. I'm going to describe both parts in detail now. On the next slides, you will see the interface and class hierarchy for collections. Unlike arrays, all collections can dynamically grow or shrink in size. As said before, a collection can hold a group of objects. A map can store pairs of objects that have some kind of relation which ties them together, named key and value. A value does not have a specific position in this map, but can be retrieved with the key it is related to. Relax if you don't get it now. We will look at it in more detail later on. So here you see the hierarchy of classes and interfaces extending or implementing the collections interface. Just try to remember some of the names listed here. This is just an overview so far. As you can see, the collection interface sits on top of a number of sub-interfaces and implementing classes. A collection can hold a group of objects. The collection interface is extended by the interfaces set, list, and queue. A set is defined as a group of unique objects. What is considered as unique is defined by the equals method of the object type the set holds. So in other words, a set cannot hold two equal objects. A list is defined as a sequence of objects. So unlike a set, a list can contain duplicate entries. Besides, a list keeps its elements in the order they were inserted into the list. A queue has two sides. Entries are added to the end and removed from the top of the queue. This is often described as first in, first out, which is pretty much like a waiting line in real life works. The first person queuing up will also be the first person leaving the queue. Now let's have a closer look at the interfaces and classes that extend or implement the set interface. HashSet, linked HashSet, and TreeSet are all implementing the set interface. HashSet is the default implementation that is used in the majority of cases. Linked HashSet is like a mix of a hash set and a list. as it does not allow duplicate entries like a set, but it returns its elements in the order in which they were inserted, like a list would do. TreeSet will constantly keep all its elements in sorted order. But keep in mind, there is no free lunch. So every added feature comes at a certain cost, of course. After looking at the classes implementing the set interface, let's also have a look at the two extending interfaces we haven't talked about yet. As the name implies, sorted set is a set that is constantly sorted. The navigable set interface was added with Java 6. It allows to navigate through the sorted list. For example, it provides methods to retrieve the next element greater or smaller than a given element of the set. Next, let's have a closer look at the classes that implement the list interface. ArrayList is the default implementation of the list interface. Like any list implementation, it does allow duplicate elements, and it does allow to iterate the list in the order of insertion. As it is based on arrays, it is very fast to iterate and read from an array list. But adding or removing an element at a random position is very slow, as this will require to rebuild the underlying array structure. Vector is a class that exists since JDK 1, which is even before the collection framework, which was added with Java 2. In short, its performance is suboptimal, so please never use it. Use ArrayList or linked list instead. So let's directly remove it and forget about it. The next list implementation is linked list. As the name implies, its implementation is based on a linked list, which makes it easy to add or remove elements at any position in the list. Last but not least, let's have a look at the classes implementing the queue interface. We already talked about linked list, as it also implements the list interface. However, the fact that it's based on a double linked list makes it quite easy to also implement the queue interface. Linked list is the default queue implementation. Priority queue is a queue implementation that keeps its elements automatically ordered. It has similar functionality like a tree set, but it does allow duplicate entries. Now let's look at the map interface. This interface has no relation to the collection interface. A collection operates on one entity, while a map operates on two entities. A unique key, for example a vehicle identification number, and an object that is related to this key, for example a car object. With the help of the key, you can retrieve the object it relates to. The interface map is the root of a lot of interfaces and classes, which we'll look at now. The class hashtable was the first collection in Java JDK 1 that was based on the data structure hashtable. So the Java creators called it hashtable. Unfortunately, this makes it a bit hard to differentiate between the two. Like vector, the class is deprecated because of its suboptimal performance. So let's also remove it and forget about it. Instead, use one of the other classes that implement the map interface. HashMap is the default implementation that you should use in the majority of cases. A map usually does not make any guarantees on how it internally stores its elements. An exception to this rule is linked hashmap, which allows to iterate the map in the order of insertion. Last but not least, tree map is a constantly sorted map. Now let's look at the interfaces that extend the map interface. As the name implies, the interface sorted map extends the map interface and defines the contract of a constantly sorted map. Navigable map again extends the sorted map interface and adds methods to navigate through the map. This allows you to retrieve all entries smaller or bigger than a given entry, for example. Actually, there are many similarities between the map and the set hierarchy. The reason is that the set implementations are actually internally backed by a map implementation. Last but not least, you might have noticed the Java collection classes often contain the data structure they are based on in their name. To choose the best collection for a given situation, you have to compare the specific characteristics of data structures like array, linked list, hash table, or tree first. In short, there is no single best option. Each one has its very own advantages and disadvantages. I promise to talk about this very exciting topic in a later episode, so stay tuned. This overview of the collection and map classes did only show you a part of the whole story. In a later episode, I will introduce you to the concurrent containers of the Java Collections framework. Generics is a topic at least as big as the Java Collections framework. In the context of this episode, I will therefore only explain you the bare minimum you need to understand the Collections framework. It's okay if you have a lot of open questions after my brief overview. Give both of us some time. I promise to explain everything one after the other. I would recommend you to subscribe to my YouTube channel to be informed as soon as I upload the next episodes of the Java Collections framework. Now fasten your seatbelts. It's going to be a bumpy ride, I promise. You see this weird stuff in angel brackets? Just relax. Actually, it's much easier than you might think. In the first line, you see I have defined a list variable mylist, and with the string parameter in angel brackets, I tell the compiler that my mylist reference variable is supposed to be used only with strings. Then I create an object of type ArrayList, and again I tell the compiler that this object is only supposed to be used with strings, and the compiler will ensure that no one ever tries to put anything else than a string into my list. In other words, this is what makes the container type safe. Also note that I use the interface list for the variable and not ArrayList. This makes your code more flexible. Only at one place you create the object, but at various places in your code you will use it. When you use list instead of ArrayList for the reference variable, you could later replace the ArrayList by a linked list, for example. And all you had to adjust was this one line of code. In case you don't really need the specific methods of a list, you could also use the collection interface instead. Always use the least specific interface for the reference variable. Oh, by the way, I'm sure you noticed the integer 100 that I use as a constructor argument. This I have added for performance optimization. As said before, the collection classes can dynamically grow and shrink in size. However, ArrayList and all hash table based collections are internally operating on arrays. When an array based collection grows in size, it will internally, on the fly, create a larger array and transfer all contents from the old to the new array. This of course takes some extra time. Modern hardware is so fast that this usually should not be a problem. But on the other side, if you already know the exact or at least the approximate size of your array-based collection, this is usually better than trusting on the collection's default size. In the next episodes, I will look at the data structures that the Java collections are based on, which will help you to better understand performance considerations like this one. However, to me, taking care of such small little details makes the difference between a developer and a software craftsman. So I wanted to let you know as early as possible. Okay, enough blah blah blah. Let's get back to the topic of generics. Now in the second line, you see how a hash map is instantiated accordingly. As said before, a map is basically a relation of one identifying key to one value element. Both these elements can be of different types. Like here in my example, I use VIN, the vehicle identification number, as the key, and a car object as the value. This has to be added as a comma-separated list in angel brackets, and the compiler again will check that this holds true. If you create the instance reference variable and the object both in one line, you can also leave the second pair of angel brackets empty, as it can be inferred from the generic type of the reference variable. This was introduced with Java 7 and is called the diamond operator, because the empty angel brackets in a way look like a diamond. Actually, I'm sorry, but that's not the whole story. There are two parts. And what I just showed you, this was actually part 2. The usage or invocation of a generic class, where you log in the concrete parameter to be used. But this is only possible if the method, the interface or the class was defined to be used in a generic way beforehand. Here you see a generically defined interface. In the first line, the interface is defined as an interface operating on two separate generic types that have to be specified at a later time. However, when these types are locked in, this will automatically also specify the types interface methods will use. So if you see some weird one-letter types in one of the next slides, just remember it means this is a method that can be used in a generic way. Okay, now we are ready to look at some additional utility interfaces of the Java Collections framework. They are implemented by classes of the Collections framework or the JDK in general, but they can also be implemented by your own classes, making use of the power of the Collections framework. Well, strictly speaking, the interface java.lang.Iterable is not part of the framework, but more precisely, it sits on top of it. It is the super interface of java.util collection, so every class that implements java.util collection will also implement the java.lang.Iterable interface. Okay, anyway, let's now look at each interface in detail. An iterator is an object that acts like a remote control to iterate through a collection. Let's look at its methods. Boolean hasNext returns true if the collection has more elements. eNext returns the next element in the iteration. And void remove removes the last element returned by this iterator from the underlying collection. This interface provides only one method, which will return an iterator. Every collection that implements this interface can be used in the for each loop, which greatly simplifies the usage of your homemade collection. In order to plug in your collection into the for each loop, you will have to execute two simple steps. First, create an iterator that is able to iterate over your collection with methods like hasNext and next, as we saw on the last slide. Second, you need to implement the iterable interface by adding an iterator method that will return an instance of this iterator. Implementing the interface java.lang.Comparable defines a sort order for your entities. The interface contains only one method you need to implement, which is int compared to. If you want to define a natural sort order for an entity class, make it implement this interface. Return a negative integer if the object is less than the given method argument, 0 if the object is equal to the given method argument, and a positive integer if the object is greater than the given method argument. What means smaller or greater is for you to define. For numbers, that would probably mean that 1 is smaller than 5, for example. But for colors, this all depends on how you want to sort your entities. When you put objects of an entity that implements the comparable interface into a tree set or a tree map, it will use your compareTo method to automatically sort all elements you put into the collection. As you can see, the Java Collections framework has been greatly designed for extension. It offers a lot of possibilities to plug in your own classes. This interface is very similar to the comparable interface. It allows you to define additional sorting orders, like a reverse ordering. So the sorting logic is not directly implemented in your entity, but in an external sorting strategy class that can optionally be added to a collection or a sorting method to define an alternative sorting order for your collection of entities. The rules of the interface contract are pretty much the same as for comparable. Return a negative integer if the first argument is less than the second argument, 0 if both arguments are equal, and a positive integer if the first argument is greater than the second. Last but not least, let's look at the two utility classes collections and arrays. Like a Swiss Army knife, they provide static helper methods that greatly enhance the general usefulness of the collection classes. Java.util.Collections offers methods like sort, shuffle, reverse, search, min, or max. And Java.util.Arrays operates on arrays and not on collections actually. Similar to the collections class, it allows to sort arrays or to search through arrays, for example. Okay, that's it. If you like this episode, click on the orange box to subscribe to my newsletter. If you have any questions, you can leave them as a comment below this video. And please don't forget to give me the thumbs up in the bottom right corner of this video. Okay. Thanks for watching and see you next time.